Here is a quadratic expression ax square plus bx plus c, and the zeros of this expression are alpha and beta. Now we have learned that the sum of roots, which we write as alpha plus beta, is equal to minus b by a. Minus b by a means minus coefficient of x over coefficient of x square, that is a. We also have learned that the product of roots which we write as alpha into beta equal to c by a. Now c is a coefficient, is a constant term, not coefficient, is the constant term, that is c, and over a is coefficient of x square. So in all today's sums, we are going to use the formula alpha plus beta equal to minus b by a and alpha beta equal to c by a. If the product of the zeros of a polynomial is 4, find the value of a, find the sum of the zeros of the polynomial. So here we have the polynomial. This is our polynomial, that is ax square minus 6x minus 6. Let's write down its coefficient. So first the coefficient of x square a b is here. This is the coefficient of x, so the b equal to minus 6, and this is the c equal to minus 6 too. Now in the second step they have said that the product of zeros is 4. So let's write it out. Product of zeros equal to 4. The product of zeros we know is alpha into beta, and alpha into beta is equal to c by a. Alpha into beta is 4, which is, and we know c is minus 6, a here c is minus 6 and this is a. So we put the values, and now a equal to minus 6 by 4, which is minus 3 by 2. We also need to find the sum of the roots or sum of the zeros. Now the formula for sum of zeros which we need to find, and we know it is alpha plus beta equal to minus b by a. This is the formula for sum of the zeros. So alpha plus beta, which we need to find, equal to minus. Now we see b is minus 6. So that would be minus of minus 6 over a. And a, we already have found a here is minus 3 by 2. So we put that minus 3 by 2. So alpha plus beta equal to minus or minus is plus over 3 by 2, which is equal to 6, divide by 3 by 2, 6 into 2 by 3, and this is minus. You cancel this, you get the answer minus 4. So alpha plus beta equal to minus 4. Find a quadratic polynomial whose zeros are 3 plus root 2, 3 minus root 2. So this is alpha and here is beta. So alpha equal to 3 plus under root 2 and the beta equal to 3 minus under root 2. Now we need to find a quadratic having these zeros. So for this, first we know the general formula, and that is x square minus sum of roots plus product of roots. So let's put the values. Now we know x square minus The sum of roots is alpha plus beta x. Product of roots is alpha into beta. So x square minus, the alpha is here 3 plus under root 2, beta is 3 minus under root 2. So 3 plus under root 2 plus 3 minus under root 2, that's alpha plus beta, into alpha into beta, 3 plus under root 2 alpha, beta 3 minus under root 2. So x square, this is x of course, minus, this cancels out, so we have 3 plus 3, and that is 6x. And here we have a plus b and a minus b, and this is a square minus b square. So we write a square minus b square. So this is x square minus 6x plus, this is 9 minus 2, that is x square minus 6x plus 7. So this is the quadratic that has roots 3 plus root 2, 3 minus root 2. Find a quadratic whose roots are 3 plus root 5 over 5, 3 minus root 5 over 5. So we have alpha is 3 plus under root 5 over 5, and beta is 3 minus under root 5 over 5. We'll do it a little differently now. We'll find the sum of roots. The sum of roots is 3 alpha plus beta. And LCM will be 5. So this will be 3 plus under root 5. And this should be minus, it's not plus here, this is minus. So we just do it again, so the LCM is 5. So 3 plus under root 5, 3 minus under root 5, this is alpha plus beta. So we cancel this out, so 3 plus 3 is 6, 6 over 5. This is the sum of the roots. We find the product of the roots. Product of the roots is alpha into beta. So here one root and we write the other root. One root is 3 plus under root 5 over 5, that is alpha, 3 minus under root 5 over 5, that is beta. So a plus b, a minus b, a square minus b square. And 5 into 5 is 25. So we have 9 minus 5 over 25. Remember, we are finding product of roots, which is 4 over 25. Now for our formula, the quadratic is x square minus sum of roots plus product of roots. Now let's put our values. So here we have, that will be x square minus sum of roots we see is 6 by 5. Product of roots is 4 by 25. So we have here 6 by 5x plus 4 over 25. This is our quadratic. We could also take the LCM and write it out. So this would be 25x square minus 30x, because into 5 plus 4. So 1 over 25, here would be 25x square minus 30x plus 4. Show that 1 by 2 and minus 3 by 2 are the zeros of the polynomial. So for this we know the polynomial p of x is equal to 4x square plus 4x minus 3. To show that 1 by 2 is a 0, all we need to do is find p of 1 by 2, which is 4. Wherever there is x, we put 1 by 2. 4, 1 by 2, minus 3, which is 4 over 4, 4 over 2 minus 3, 1 plus 2 minus 3. So p of 1 by 2 equal to 0. Therefore, 1 by 2 is 0 of the polynomial. Next is to show minus 3 by 2, and we do the same thing. So here is our polynomial 4x square plus 4x minus 3, and we'll do p of minus 3 by 2. So wherever there is x, you put minus 3 by 2 whole square. Here 4 minus 3 by 2 minus 3. So we work this out. Here we get 9 over 4 minus, we multiply 12 over 2 minus 3. This is 9 minus 12. So back again, we cancel this 4. This would cancel as 6. So we have 9 minus 6 minus 3. So p of minus 3 by 2 equal to 0. Therefore, minus 3 by 2 is 0 of polynomial. Here now we got to verify the relationships. So here we have the quadratic. We know coefficient of x square is 4, coefficient of x, and here we have c is minus 3. And the zeros are given to us as alpha 1 by 2 and beta is minus 3 by 2. So let's check up on the first relationship, that is alpha plus beta, and see what is minus b by a. Now alpha 1 by 2, beta 3 by 2, LCM 2, so minus 2 equal to minus 1. Minus b by a, here is b and here is a. So minus b by a, so minus 4 by 4, which is equal to minus 1. So alpha plus beta equal to minus b by a. And for the next one is product of roots. So alpha into beta. Check if it is c by a. So alpha is 1 by 2. Here is alpha. Here is beta. So 1 by 2 into minus 3 by 2 is beta. When you multiply, you get minus 3 by 4. Now c by a. This is c and this is a. So we do now minus 3 by 4, and yes, alpha into beta equal to c by a. Find the value of b for which 2x plus 3 is a factor of the polynomial. So we have p of x equal to 2x cube minus 9x square minus x minus b, and it is given to us that 2x plus 3 is a factor. If 2x plus 3 is a factor, we can say 2x plus 3 equals 0, 2x equal to minus 3, x equal to minus 3 by 2. So p of minus 3 by 2 will be equal to 0. So let's go ahead and find this. So again, p of x we know is 2x cubed minus 9x square minus x minus b. So we're going to find p of here minus 3 by 2. So minus 3 by 2. 2, wherever there is x, I put minus 3 by 2. Here there is x, so it is minus 3 by 2 square. Minus x minus 3 by 2. Minus b, and this will be equal to 0 because it is a factor. So we now find the value. This would be minus 27 over 8 minus 9, and this would be 9 over 4 plus 3 by 2 minus b equal to 0. In the next step, we'll have 2 into minus 27 by 8 plus 81 by 4 plus 3 by 2 minus b equals 0. And when you work this out, you will get here, you cut this, you get minus 27 by 4 plus 81 by 4 plus 3 by 2 equal to b. I took the b on the other side, so here you get 4 minus 27 plus 81 plus 6 equal to b. So this works out as 60 by 4 equals to b, b equal to 15. If 2 and minus 3 are the zeros of the quadratics, so alpha, 2, beta, minus 3 of the quadratic. This is a quadratic, so let's write a quadratic which is x square plus a plus 1x plus b. We need to find the values of a and b. So let's go ahead and write the coefficients. So our a here is 1. Then b is the coefficient of x, and we see the coefficient of x is a plus b. And our constant term c is b. Now we know our relationships, that is alpha plus beta equal to minus b by a. Here I am using capital A, B, C because they have already used up the small a, b, c, so I need to use capital. Now alpha is 2 and beta is minus 3. So I have 2 minus 3 equal to minus b by a. So minus b by a would be minus, b is a plus 1, a is 1. So we need to solve this. So minus 1 equal to minus a minus 1. So minus 1 equal to, continue it here. I'll take minus 1, I take this one on the other side, it becomes plus 1 equal to minus a. So 0 equal to minus a will be 0. So this is one part. Now for the second part, we have product of roots. Alpha into beta is c by a. Now we know our alpha is 2 and our beta is minus 3. So we have 2 into minus 3 is c by a. Now c we know is b and a is 1. So we put b over 1. So minus 6 is equal to b. If alpha beta are the zeros of the polynomial such that alpha plus beta equal to 6, alpha beta is 4, then write the polynomial. So sum of roots is 6, product of roots is 4. And we know a polynomial is always written as, say g of x is a polynomial, it is always written as x square minus sum of roots plus product of roots into k. So we write x square minus the sum of roots is 6 and product of roots we know is 4. So here is our polynomial, x square minus 6x plus 4. If alpha beta are the zeros of the polynomial, find the value of alpha plus beta plus alpha beta. So we have our polynomial is seven y square 2y square plus 7y plus 5. We go ahead and write a coefficient. This is our a, here is b, and this is c. Let's write that out. A equal to 2, b equal to plus 7, and c equal to plus 5. For the next step, we know alpha plus beta equal to minus b by a. So alpha plus beta, we see our b is plus 7 and our a is 2. So minus b by a will be minus 7 by 2. We'll use this information later. We know also that alpha into beta is C by A. So alpha into beta, you see our C is 5 and our A is 2. So that will be 5 by 2. In this sum, we need to find the value of alpha plus beta plus alpha beta. Now alpha plus beta we have found here, that is minus 7 by 2. So minus 7 by 2. And alpha beta we found here 5 by 2. So that is plus 5 by 2. This is alpha beta. So minus 7 plus 5 by 2 minus 2 by 2, which is equal to minus 1. So the value of alpha plus beta plus alpha beta is minus 1. For what value of 3, for what value of k, 3 is the 0 of the polynomial. So our polynomial p of x is given here, that is 2x square plus x plus k. And 3 is a 0, so p of 3 we need to find, that is 2, wherever that is x, we will put 3. Since it is a 0, we can say, so we have now, since 3 is a 0, p of 3, we find p of 3, which means wherever there is x here, we put 3. Here 3 plus k. This will be equal to 0. So 2 into 9 plus 3 plus k equal to 0. 18 plus 3 plus k equals 0. 21 plus k equals 0. K equal to minus 21. For what value of k minus 4 is the 0 of the polynomial? So this is a polynomial. P of x, we put it as p of x, and that is x square minus x minus 2k plus 2. And minus 4 is a 0, so p of minus 4 will be equal to 0. So wherever there is x, we put minus 4. 2k plus 2, and this will be equal to 0. So this is 16 plus 8, open the bracket, equals 0. So 16 plus 8 minus 2, and here we get, this is 4 plus 4. So this will be 18 minus 2k equal to 0, 18 equal to 2k, so k 18 by 2, k equals 9. Here's a similar sum. For what value of p minus 4 is a 0? So we have, say, f of x, this is a polynomial, x square minus 2x, 7p plus 3, and minus 4 is a 0, so f of minus 4, which means wherever there is this x, we have to put minus 4. So minus 4 square, here is minus 4, 7p plus 3. This is 16 plus 8 minus 7p minus 3 equals 0. Here we get 21 minus 7p equal to 0, 21 equal to 7p, p equal to 21 by 7, p equal to 3. If 1 is a 0 of the polynomial, find the value of a. So here is a polynomial p of x, which is ax square minus 3, a minus 1 minus 1. Now they say 1 is a 0. That means we have to find p of 1. Wherever there is x, we need to put 1. Where there is x. So here this will be a minus 3a plus 3 minus 1 will be equal to 0. So this becomes minus 2a plus 2 equal to 0. Minus 2a, take the 2 on the other side, minus 2. Then a is minus 2 over minus 2, which is equal to 1. Write a polynomial. The product and the sum of whose zeros are minus 9 by 2, minus 3 by 2. So first we will see that the product is minus 9 by 2. So product of zeros which is alpha into beta is minus 9 by 2. And then they say the sum is minus 3 by 2, sum of zeros. Sum of zeros is alpha plus beta, and that is minus 3 by 2. We know the formula of the quadratic is x square minus sum of roots x plus product of roots. So which is x square minus sum of roots is here minus 3 by 2. So minus 3 by 2x. Product of roots is minus 9 by 2. So minus 9 by 2. So we have x square minus into minus plus 3 by 2x minus 9 by 2. This is a quadratic, but if you want to present it properly, you can take the LCM. So 2x square plus 3x minus 9, which is 1 by 2, 2x square plus 3x minus 9. If alpha beta are the roots of the polynomial, then calculate a alpha plus beta. So here is a polynomial ax square minus bx plus c. We know the formula that alpha plus beta equal to minus b by a. Now in this polynomial, the coefficient of x square here is a. The coefficient of b, the coefficient of x is minus b. And c is a constant term c. So let's put our values. So we have alpha plus beta is minus, b is minus b. So minus of minus b, and our a is a. So alpha plus beta is b by a. If the sum of the zeros of the quadratic is 3, find the value of k. So our polynomial, say p of x is 3x square minus kx plus 6. And the sum of zeros, they said, is 3. So which means alpha plus beta, we know, is minus b by a. However, in the exam, you need to write like this. It's the coefficient of x over coefficient of x square minus. The sum of 0 is given as 3 here. So we write 3 equal to minus b by a. And if you see here, our a is 3, b is minus k, and c is 6. So minus b by a will be minus of minus k by 3. So here we have 3 equal to k by 3. So k equal to 3 into 3, that is 9 equal to k. Here, just to repeat again, this is our a, this was our b, and this is our c. If minus 1 is a 0 of the polynomial, then calculate the other zeros. So first f of x, we know, is x square minus 7x minus 8. Now 1 0 is minus 1, so alpha equal to minus 1. Beta we need to calculate. This polynomial, let us find the coefficients. Here coefficient of x square here is 1, here b is minus 7 and c is minus 8. Here is a, this is b and this is c. So let's use the formulas. We know alpha plus beta is minus b by a, and the alpha we know is minus 1, but beta we do not know. Minus b by a, b is minus 7 and a is 1. So we put minus of minus 7, because that's b, over 1. So minus 1 plus beta equal to 7. So we have beta equal to 7 plus 1, and beta is equal to 8. If the zeros of this polynomial are alpha and 2 by alpha, then find the value of a. So 1, 0, we have two zeros here. One is alpha, another one is 2 over alpha. So here we call it, these are the roots or the zeros. The polynomial is given as x square plus 4x plus a. Now when we compare it with the standard quadratic, that is ax square plus bx plus c, we see that a equal to 1, we have b equal to, in this case we are going to use capital letters because they have already used the small letters, so we will write it as ax square plus bx plus c. So when we compare, we get a equal to 1, b equal to 4 and c equal to a. Now we know the formula, the sum of roots alpha plus beta is minus b by a. Now the alpha here is our alpha and this is our beta. So we have alpha plus 2 over alpha is minus b by a, minus 4 by a. But we cannot go further with this. So what we are going to do, we have got two unknowns here. We got a is unknown, here a is unknown, and alpha is also unknown. So we cannot do this. So we have to go to product of roots. Now we know the product of roots, that is alpha into beta, is c by a. So alpha, and we know beta was 2 by alpha. So 2 by alpha is c by a. C is a and this is 1. Here I put c is a and a is 1. So this cancels out and the a is equal to 2. Find a quadratic polynomial. The sum and product are 6 and 8. So here is given sum of roots equal to 6, that is alpha plus beta equal to 6, and product of roots equal to 9, that is alpha into beta equals to 9. The formula of a quadratic is always x square minus alpha plus beta x plus alpha beta. So we put our values, x square minus, we see that the sum of the roots is 6 and the product of the roots is 9. So it will be x square minus 6x plus 9. This is our quadratic. Find the quadratic whose sum and product are 21 by 8 and 5 by 16. So sum is 21 by 8, which means alpha plus beta is 21 by 8, and product equal to 5 by 16, which is alpha beta is 5 by 16. Formula: x square minus sum of roots plus product. So which means it is x square minus sum of roots is 21 by 8x, product is 5 by 16. So x square minus 21 by x over 8 plus 5 by 16. You can do it this, or you can take the LCM. Form a quadratic polynomial with 3 and minus 2 by 5 as sum and product. So sum is given as 3, which means alpha plus beta is 3, and product is equal to minus 2 by 5, which is alpha beta. So we have x square minus sum plus product. So this is x square minus sum is 2 by 5 x. Oh no, this no, sum is 3, not 2 by 5x. So this is wrong. Is 3. So we have 3x. Product is alpha beta is minus 2 by 5. So we have x square minus 3x minus 2 by 5. If the sum and the product of the polynomial is 10 each, so here our polynomial, say p of x is ax square minus 5x plus 6 plus c. They said the sum and product both are 10. That means alpha plus beta equal to 10, and alpha into beta is also equal to 10. We have to find the value of a and c. Now in this polynomial, first we need to find the value of a, b and c. So when we have the polynomial, this was our polynomial was given as ax square minus 5x plus c. And if we compare it with the standard polynomial ax square plus bx plus c, we say a equal to a, b equal to minus 5, and c equal to c. Next we go on to alpha plus beta. Alpha plus beta we know is minus b by a. Let's put the values. Now alpha plus beta is given as 10 here. So we put 10 minus b by a. This is our b and this is our a. So minus b by a will be minus of minus 5, which is b, and a is a. So here we have 10. Let's continue here. Equal to minus 5 over a. So we have a equal to 5 over 10, a equal to 1 by 2. So we found out that a is 1 by 2. We also know this was a quadratic, so we had a equal to a, b minus 5, c equal to c. So a is 1 by 2 and c is equal to c, and the product was given as 10. So alpha beta equal to 10. So alpha into beta is c by a. C by a equal to 10. Now c is c, we do not know c, but a we have found out is 1 by 2, and that is equal to 10. So c equal to 10 into 1 by 2, and c will be then equal to 5.